Okay, so what I'd like to do today is start by going through a few slides about event handling in Swing in Java, and then I think we've got time to do a second one of these quizzes to try and recapitulate some of the stuff that we did earlier in the term, in the last week or two. So last week I talked a lot about ideas to do with the graphical side of this kind of events and user interactions. So we talked about the idea of how do you set things out on the screen? How do you put buttons and text boxes and labels and things like that? And how do you lay them out in a certain way? Whereas what I want to do today is to talk about the other side of it. So I said there were basically two sides to this. One is the set out of the components on the screen. So we've got this idea of a hierarchy of containers, starting with the J-frame that represents the window, and then you usually put a panel inside that, and then you have that broken down into regions using one of these layouts, and then in each of those regions you probably put in a panel, and you might associate that with other layouts, and then eventually you get down to the components that do something. But we didn't actually say anything about how those components that do anything actually do it. So let's think about this in terms of what's called event handling. So let's do work. So we have this idea that when you've got a graphical user interface program, there was basically a model where it was reactive, basically. So the program was there, it's in a state where it's waiting for something to happen, and then something does happen, and it reacts in some way, and then it returns to that waiting state. So you might have a system where you press a button, or you close a window, or whatever, and the system reacts to that. And so we call these things events. So the kinds of things that you have as events are things like clicking a button, choosing an option from a menu, moving a scroll bar, resizing a window, or pressing some keys on the keyboard. And so when these happen, we need some way of telling the program how to respond to that. How does it react to that event that's happened? So when you read about this, there's this word event comes up a lot, and I suppose it has both an informal and a formal meaning. So we've talked about events so far as being the things that the users do. So I click on a button, that's the event. I type some text into a window, that might be an event. But then there's also a set of objects that's called events, which are essentially the formalisation of that. So how we formalise this is by having these things called events, or more importantly, these things called event listeners. So we can think of this, the model here in the language comes from the idea that the program is basically sitting there, it's listening out for things. So you've got a number of possible things that are listening out for events happening, and then what the code you write within this event listener is basically a description of what happens when that event occurs. So you might have a program which responds to clicking on buttons. So you would have an event listener associated with the notion of clicking on the save button. You would have another event listener associated with the notion of clicking on a cancel button, and so on. So you create these event listeners and make them active and remove them from the system according to where you are in the program. So if a window pops up and says, you know, do you want to save or cancel, then you need to create two event listeners at that point corresponding to the events, the actions you want to happen when you click the save button and when you click the cancel button. So at any one time, all these events are happening. So the Java system is in some way that I don't really know much about, is listening out for these events. So there's something going on that's waiting for events, but if it's not associated with an event listener, then it's thrown away. So you have to specify, obviously, what happens with each event. But perhaps it's not obvious. Perhaps there might, you know, in some systems you might consider there might be a default behaviour of some kind, but that's not the case here. Oh, this isn't working here. So what sort of things are these events? Well, we can think of them at two levels of abstraction, basically. The vast majority of events are at this high level, what is sometimes called semantic events. And these are to do with doing things to abstractions in the graphical user interface. That's a bit high level, but I'll explain what that means. And the typical ones, the things that are probably most common are these action events, of which there are various kinds, various subclasses. And these action events correspond not to primitive things that you're doing with the mouse or the keyboard, but they correspond to things that are happening within the interface that you've created. So this is an important distinction, yeah? Most of the time, for most programs, you're probably going to work at that level. Someone clicks a button, someone presses return because they've entered a piece of text, someone chooses an item from a menu. Ideally, in doing that, you don't want to track the detailed movement of the mouse. You want the system to deal with all that for you. You don't want to get the coordinates of the mouse and then work out which button that is nearest to and therefore click that button. You don't want to deal with all that most of the time. And that's what this level of abstraction provides. However, there are times when you might want to deal with that very low level stuff. So let's say you were writing a program to do drawing, so to allow the user to draw on some part of the screen. So you might have something, let's make this very primitive, you might have something here, you might have one or two menus there, and perhaps a button or two down here to change. So that changes the colour of the pen you're using. Very simple model. And then you've got a canvas, not in the formal sense, just in the informal sense, to draw on. So you can, you can move the mouse around and, make a drawing. So what kind of things does the program need to deal with there? Well, for things up here, these are these kind of semantic events, yeah? You're selecting from a menu that might say, save my drawing or something. Similarly, these buttons down here are also these semantic events. They're also clicking on buttons, as are things at a slightly higher level in one sense of the word, such as closing the window. So you want the program to respond to the window being closed. It's slightly shocking when you write a Java program and you forget to put in code to close the window when you click on that, which you've got such a familiarity with the idea that clicking on this closes the window that it's rather a surprise that that's a something you have to explicitly code for at all. But of course it is. So you've got these kind of semantic events here, but you've also got what we might call low-level events. Which are things that you might use here. So, the user clicks a button on the mouse to say that they want to start drawing, and at that point you need to track the detailed coordinate positions of the mouse relative to the position of the window so that you know how to draw. So when you're doing this kind of detailed thing, you need to get into the details of how the specific physical components, in this case the mouse or the trackpad or the finger moving on a touch screen, how they're working. And so there are some low-level events that allow you to do that, but most of the time you don't need to worry about that sort of thing. So that's basically a distinction between these semantic events, things like action event and window event and item event and change event. So I think these are fairly obvious what these things are doing, yeah? Clicking a button, pressing return in a text field, closing a window, selecting a checkbox or something like that. And then the low-level events are more things like this, yeah? So there are things like mouse events. There are a lot of things to do with the basic behaviour of the mouse, yeah? So you've got a mouse event, which happens when a mouse button is pressed or when the mouse comes into some area. So this might be a component and you want to know when the mouse is in the drawing area. Or you might want to, perhaps more importantly, know when a mouse button is pressed. So let's say that this system works by you click to start drawing and you click to stop drawing. Well, somehow you need to have one of these mouse events to check whether the mouse button has been clicked within this area, and then you need some kind of way of tracking when the mouse has been moved to know when the user is starting to do some drawing within that, and then you can use some other things we'll talk about in a moment to get information about the coordinates where the mouse is. Similarly, there are things to do with keys on the keyboard. So you might think about most of the time, well, no, most of the time, don't know. A lot of the time you're going to, if you're using the keyboard, you don't want to react immediately to that. You want to put something like a text field up, so we saw that in the form that we looked at in the lecture on Friday or Thursday last week. We did something about forms and how you can create text fields. And you'll look at that in class later on today. And the idea behind that was that you filled in the text and then you clicked a save button at the end. So in those cases, you don't need these sort of things. kind of keyboard events, these key events. You don't want your program to do anything with that text other than what's built into the text field, which is recording it on the screen. You only want your program to deal with it when you've typed a whole line of text and then pressed return or clicked on a save button or something like that. But let's say you were writing some kind of game, some kind of arcade style game where you're reacting, your character is moving around the screen according to which buttons are pressed. So in that case, you want the program to do something quite specific when your keyboard keys are pressed, yeah? You want to say, move the character up when I press the up arrow, move the character left. In that case, you want to respond immediately to these keyboard events. So in that case, you'd use something like this key event to deal with those situations. So in these situations, you're going to use these low-level events. But for the standard graphical user interface type thing, you're going to be typically using these higher-level semantic events. So how do you go about this? Well, we'll look at the details. I'll put 1 or 2 bits of code up here. I basically want to describe the principles, and then we can have look at some detail of this in one of the practical classes. But basically, to create a listener, one of these event listeners, you have to define a class that implements a listener of the right type. So these are interfaces. Have you learned about interfaces in this sense of the word? Interfaces in the sense of a kind of abstract class, but even more abstract in a sense than that. So an interface is a kind of specification of some behaviour, some method names that you would expect to be implemented by a class of that type. So this is one of the real examples where this comes in. So this is a kind of inheritance, but it's not inheritance from a class, it's inheritance from an interface, and they're subtly different. And most notably in Java, you can have multiple interfaces, yeah, on one class, though that won't be so relevant here. So these listener classes, they basically contain a description, formal description of what happens when the event happens, yeah? So you have an event listener that might be associated with a particular action, like clicking a button, or you might have some that deal with something more complex, like a window. So a window can do multiple things, yeah? You might want to care about different things happening with a window. So you might care when that little cross has been clicked there, that close button, and you want to deal with that appropriately by shutting down, saving certain things before you actually close the window, perhaps. Quitting the program, perhaps if you just have a single window program, you click on the close button, you want that to close down the whole program. Similarly, you might resize the window. So you might drag the window down or make it bigger or smaller. Now, some of the things will happen automatically. So for example, if this is a panel, you'll have a certain size, a certain maximum and minimum size, as we said last week, and that will scale automatically. But you might want certain things to happen when a window is resized. So there's, you might want specific things to happen when a window is resized. You might want to try and keep something a fixed size or something if it's a certain kind of structure. So you've got some way of responding to that. So the window has different things can happen to it. You can open and close it, you can cancel it, you can resize it. So you can have these more complex complex listeners that deal with that sort of thing. So, let's think about the inaction events. These are probably the most commonly used kinds of events. So what do these contain? Well, basically, you're linking together a component. So remember, components are parts of the visual parts of the graphical user interface. Components are things like buttons and windows and menus and things like that. Yeah? So a component, by its nature, by how it's been coded, will generate certain kinds of action events. So a button will generate an event when it's clicked. And that's the semantic abstraction we're talking about. And then associated with that will be a class, a second class, which is a description of what you do when that event's happened. So that will be an extension of this action listener interface. And what this action listener interface specifies, the method that it specifies primarily, is this thing called action performed. So that basically says that you're going to override that and say what happens when that particular action's happened. So let's say you're clicking on a button, you click on a button, and so the button itself is associated with a component in the code, and then you associate an event listener. You associate an event listener with that to say what's happened. And so, how are we going to associate these things? Well, it's a fairly standard thing. This component will have a method in it. The components all have a method in it, which is to add an action listener. So you might have a button here. So X might be the button object, and then you're going to add some listener to it, which defines what happens when that button is clicked. And so that basically tells you what happens when that event occurs. That's very straightforward. And then there are a number of things that you can use within the action event to modify the action, to change the action according to how it happened. Yeah. So there's this thing called string get action command. So, for example, with a button component, which I'll use as an example, this is very simple. It just returns what text is on the button. So that's a bit boring for that one. But you might have this, for example, associated with a text field. And so there's a similar sort of method which gets the text, the current contents of the text field. So that's more interesting in terms of things like text fields. You might have something called get modifiers. You might care whether one of these keys, like shift or control and so on, has been pushed down while you're clicking on a button, yeah? So you get these things in some programs where it says control click on something. It's not perhaps common now. And similarly, there's a thing about different mouse buttons and things like that. Was it clicked with the right button or the left button and things like that. So there are ways to find out things like that. So there are certain things like that that are available. And then you can also, there's a little method which allows you to say what object caused the event. I don't know whether these are particularly useful. I think a lot of the time you've structured your program so you'd know what that was. And as I said earlier, sometimes you'll have more than one method. So a window listener, the interface for the window listener has 7 methods. So it's window closing, window closed, window open, window iconified. various things to do with the state of the window. And usually you only care about a small number of these. You might, you're happy with, you're just interested in associating some code with when the window's closed. When you click on the button to close the window, that sort of thing. So perhaps you only want to implement one of these methods. So obviously you could just implement the remaining ones as just return, do nothing and return. But there is a more sophisticated way of doing that. There's something called a window adapter, and that allows you to just define the one method that you need. And then it's, again, back to object orientation, it uses a kind of inheritance to get the other methods that are needed by inheritance to the window adapter. Yeah. So it's very crass, really. It's just all this window adapter's doing is providing stubs for all these methods that just do return, and so you just override whichever ones you need for the particular task at hand. So that's that. So let's think about a bit of code for this. So how are we going to actually do this? Well, there's various ways of doing it. The simplest way to understand this is the idea of writing a class that implements the action listener. But more commonly, there's a certain way that's very idiomatic to Java and languages like this, which we'll look at in a minute, which is called using an anonymous inline class. And then you can also, these are not all mutually exclusive, you could also extend an existing class. So you might define a higher level class to deal with buttons being pushed and doing certain actions to do with that, and then you inherit, you create a number of different kinds of classes of objects for different kinds of buttons, like save buttons and cancel buttons and so on. So here's a simple example of just creating a class, just a standalone class that's called controls. That extends JPanel and implements action listener. So we're going to do something very simple here. We've got a method that's a constructor here, yeah, and this is going to be about adding controls to the panel. That's just a comment there. So what have we done here? Well, we've taken a button and we've put some text on it, so that just creates a button called press here. We need to do two things, yeah. Firstly, the wrong way around in that sense. Firstly, or secondly, we need to add the button graphically to the interface, yeah. So we've got the panel. This is a panel, yeah. So it's a region of the screen which would probably be associated with a frame, with a window. And we're going to add that graphically to the screen, to the panel. So that adds it graphically as a graphical component. In order for it to do something, we need to also associate an action listener with it. So we're going to add action listener, and then we need to therefore say what methods of what happens when we do that. So when we click the button, it's going to leap to this method here, and then it's going to do whatever is there. So it might change something, it might change the data, it might add a bit of, it might add something to the interface, it might pop up a window or something. So that's the basic framework for doing it that way. Like I say, that's not the most idiomatic way of doing this in Java. There's a way that's much simpler at one level, though conceptually a bit harder, which is to add this action listener in an anonymous way.
So what action listener actually does? What this method does? Just give the property to the button to that the
Well,
user
this method here, action performed. You talking about this? Or?
Yes.
So that method there, when the button is pressed, when you click on it with the mouse or whatever, that then, the stuff that you put in there is what you want the program to do as a result of having pressed that button. So say it's a save button, you would put some code in there to do with writing the current state of the screen to a file, yeah?
Yes, but two questions. One question is what add action listener does actually, and the other question is that if we have two buttons here, we have to have for each button a class.
Yeah. So let's think about that. So the first question, what does the action listener do?
Yeah.
Well, that makes it so that by adding the action listener, you're telling the system, you're telling the program to listen out, to wait and respond to button pushers, yeah? So if you just add a button, if you just had this line here, add button, without adding the action listener, then all you would have would be a button that's not connected to anything, yeah? So by doing add action listener, that associates this, it means that is associated with the, with the button. So actions that happen that are associated with the button in this context then activate that action performed thing there. Now you asked about multiple buttons. That's a good question. So yeah, so you could add a second line with another action listener, yeah? So you could say button 1, button 2, and you add them to the screen, and then you'd say button 1, add action listener, button 2, add action listener. And that's the point at which you might need to use these, what's the method called, get source or something, to distinguish between, which button was pressed and so on. So that's that sort of thing there. And then you can do this anonymously. So in the previous one, we'd given a specific name to it, but we might just create the class there. So if you notice, this is all within there. And the previous one, it was the panel that had extended, that had implemented the action listener, which is a sort of a bit of a, this doesn't make much sense really. It's just a bit of a place to put it. Whereas this makes, in a sense, much more sensible way of doing it. What you're doing is when you add an action listener, you're not giving it a specific name. You're just creating a new one in there and overriding the default nothing that it does by putting the code in there. So this is all contained within the brackets there. So you're creating a new action listener within that, a new action listener object within there. So this is called an anonymous class, because you don't ever give a variable name to this thing. You don't need to. You're never going to refer to it outside that context. So it doesn't need to have a variable name associated with it.
So anonymous class is actually something like extends, and I put a new method. Extends from action listener. So action listener is a parent class.
Yes.
I'm creating a new method to extend the class.
Well, it's creating
something like that.
It's something like that. Yeah, it's creating a it's creating a new object of that class in there without actually and specifying how that's overridden. So it's like creating a new subclass of that, but without actually giving it a specific, without giving it any kind of specific name or anything. Yeah.
How can we access the new method that we just created?
Because it's now associated with the button. Add action listener makes a link between the button and the action performed method.
Okay.
So when that button is then clicked, that specific action performed method will be executed. Yeah. And so you associate that particular action performed method with that button, and then you can repeat this multiple times. What's happening behind the scenes is it's creating a new kind of action listener every time. So and that's an interface. So essentially, that kind of creates a little subclass. That creates a little dynamically creates a little class called anonymous class, which has a specific overriding of the action performed method.
If we create an instance, for example, a reference, and we say this reference equals new action listener and etc. Then from the reference, do we have access to this method?
Yes.
Yes, but how? Because the reference, the type of the reference
give it a name.
listener. Now we're creating another method.
You create you give it a name, and then you say name dot action performed. But it's not how you wouldn't want to do that. It's the only time you'd want to create action to execute the method action performed is when you click on the button. So this prevents you doing that essentially. By not giving it a name, you're restricting the ability of this to happen to only when the button is clicked.
Yes, but the method will call automatically.
Well, what, sorry?
Automatically will call
Yes.
the method.
Yeah. That's what this does. That's the functionality that's implemented by add action listener, is to do what you've just said, to connect the button to the action performed method.
Okay.
That's the semantics of that method.
Okay.
Yeah? Okay? This is a bit complicated. This is a very unusual sort of... It's very idiomatic for this sort of Java GUI stuff, but it's quite unusual in other contexts. So, you know, it's worth teasing this out, what this does. So, finally for this bit, and then we'll just do one other thing before we finish. I want to think about how you associate these listeners with components. So, it's easy to think, oh, we've got all these components, we need to write a listener for all of them, much as it's easy with variables to think I've got to write a get and set method for all of them. That's nonsense, you know. And similarly, it's nonsense to think about, you know, writing an event listener for every component. If you've got something like that form that we saw last time, you need to think about when you actually do actions. So do you actually need to do anything when you type text into the name or number box? No, you don't. The only time you need to do an action, do anything with that data, is when you want to save it, or perhaps when you want to reset the form or whatever. So you don't need to associate any listeners with the text boxes at all. You just need to associate a listener with the save button, and then have some references within its action performed method to what it does with the text. So it might, within the action performed method, it will have, you'll think about how to pass the references, but you'll have a reference to the text fields, and then you'll say you get the information from the text fields and save that in some string variables or whatever. So that's the way to do that. So we've talked about events, clicking on buttons, typing text, resizing windows, closing windows. Well, we've said that most of them are these semantic events. Most of them are these things where you respond to some meaningful component within the interface. Occasionally, like with this drawing example, you need to go to these low-level events. And basically what you're doing is you're associating one of these action listeners with a component in the thing there. So, for 10 minutes, just to finish, I've got another one of these. So can you, I think there might just about be enough for one for everyone, but do pass them around. So again, same format as last time, yeah? We will pass these round and spend 5 minutes going through those, and then we'll discuss these at the end, or another 5 minutes at the end.